The message came from our security team, not from monitoring. Are S3 objects supposed to be publicly accessible? It was 9:26 in the morning. At first it sounded like a routine question. Sometimes public buckets are intentional for assets like images or downloads, but the follow-up message changed the tone immediately. I can access customer documents without authentication. Within seconds, the Slack channel went silent. Someone pasted a URL. It pointed to a file inside one of our S3 buckets. No authentication required. Anyone with the link could open it. The file contained a customer invoice. Our platform ran entirely on AWS, with most of the application services living inside a Kubernetes cluster running on EKS. Around 160 pods handled authentication, billing, document processing, and analytics. Traffic averaged about 4,000 requests per second during business hours. Customer data lived in multiple places. Transactional records were stored in PostgreSQL on Amazon RDS, while large documents were stored in Amazon S3. The document service generated invoices and exported them to a private S3 bucket. Application services would generate temporary signed URLs for secure downloads. Infrastructure was managed through Terraform and deployed through GitHub Actions pipelines. Monitoring consisted of Prometheus, Grafana, and Datadog for telemetry. Security logging relied heavily on CloudTrail and AWS Access logs. Under normal conditions, S3 buckets storing customer data were strictly private. At first, the system itself showed no operational issues. APIs were healthy. Error rates were normal. Users were able to log in and download their documents normally. From the platform perspective, everything worked. But the security team had discovered something troubling. A file that should have required authentication was directly accessible. We tested the link ourselves. It worked. Anyone with the URL could download the file without credentials. That raised an obvious concern. If one object was public, others might be as well. The document bucket contained millions of files, invoices, reports, and user-generated uploads. If the bucket policy allowed public access, a large amount of sensitive data could be exposed. The first step was verifying the bucket configuration. We opened the AWS console and inspected the bucket policy. The policy contained a statement that allowed public read access. That should not have existed. But there was another complication. The bucket level setting for blocking public access was still enabled, which normally overrides public policies. Yet somehow objects were still accessible. We pulled the recent configuration history through CloudTrail. About 30 minutes earlier, the bucket policy had been modified through a Terraform apply triggered by the CI pipeline. The change looked small. A new policy statement had been added to allow public access to a specific prefix used for static assets. But the prefix was misconfigured. Instead of allowing access only to the assets folder, the policy allowed read access to every object in the bucket. At the same time, the Terraform change disabled the block public access flag. That combination created immediate exposure. Slack channels filled quickly as engineers from multiple teams joined the investigation. The security team began running automated scans against the bucket to determine how many objects were publicly accessible. The root cause was clear. A new feature required hosting certain files directly from S3. Instead of creating a separate bucket, the engineer attempted to grant public access only to the assets directory in the existing bucket. However, the policy condition was written incorrectly. The prefix filter failed, effectively allowing public read access to the entire bucket. It was a silent exposure. Because the system itself continued functioning normally, no operational alerts fired. The exposure was detected only because the security team happened to test a direct object URL. The first priority was removing public access immediately. We applied a manual override in the AWS console to restore the block public access setting. That action instantly prevented further access. Next, we removed the problematic policy statement entirely. Within minutes, external access attempts began returning access denied responses. The hole was plugged. Then we ran a full audit of S3 access logs to determine whether unauthorized downloads had occurred during the exposure window. Fortunately, it lasted less than 30 minutes. Access logs showed only a handful of requests, most of which were internal verification attempts. The damage was contained. Recovery followed immediately. After restoring the correct configuration, we updated the Terraform code to create a dedicated bucket for public assets, instead of mixing them with sensitive documents. We also added additional guardrails to prevent similar policy changes from being applied without review. It was time for reflection on our infrastructure design. What actually failed was not S3 itself, but our infrastructure design decision. Combining public and private content inside the same storage bucket increased the risk of configuration mistakes. Detection also relied too heavily on manual checks. Although CloudTrail recorded the policy change, no alert triggered when the bucket became publicly readable. Policy misconfigurations are hard to spot. Engineering lesson. Sensitive and public data should never share the same storage bucket. Separating resources by access level dramatically reduces the blast radius of policy mistakes. Infrastructure pipelines should include automated security checks that detect overly permissive storage policies before deployment. Block public access settings should remain enabled. Access logs should be actively monitored for unusual download patterns. Finally, configuration mistakes rarely break systems immediately, but they can silently expose data if left unchecked. That morning reminded us that security incidents do not always start with attackers, but sometimes with a single line in a policy file.